here and it was 5 centimeters. So I have this triangle here, a triangle, listen to me, this rectangle here, and this rectangle here, and we're going to call this rectangle, rectangle 1. I can see that this rectangle is the same as this rectangle because they're the flaps. Both of them have that little tape there from the flap of the cereal box. So those both were the same right there. And if I want, I like surface area because surface area is one of those formulas that's the same. The idea of surface area is I just add up all the areas. Surface area, we abbreviate S for surface, A for area, add all areas. Okay, so I can see that that rectangle 1 and 2 are the same. So I can draw that one here, and I might just draw it right here this way. And I put my dimensions. I have 5 centimeters here and 18 centimeters here. So this is another way I like to draw the rectangles next to them. Area for a rectangle is base times height. I drew the picture, I write the formula. Now I'm going to substitute what I know. Base is 5, height is 18. 5 times 18, I could do 5, count from there, or I can do 5 times 10 is 50, and then 3 more. 50 and 15 is 65. That seem right?
No.
No, it doesn't seem right. So what did I do? Because if I did by 10 plus 3 more is only 18. Okay, so 180. If I do 5 times 18 times 10 is 180, and 5 is half of 10, I get to 90. Or I could do 5 times 10, then 5 times 5, then 5 times 3. If I'm thinking about that, 18 is 10, 5, and a 3. Then it's 50, 25, and 15. And I get to 90. Or I could do the multiplication.
Penultimate.
Okay.
I would have done 50 times 10, 5 times 10 and got 50, and 5 times 8 and got 40, and I would have added those two together.
And that's another way to do it.
50 plus 40 is 90.
So when I look at the picture, I see that I have 2 of these. So I have 2 of those. I'm going to draw it with the wrong one on the wrong corner. All right, I have 2 of them, but there are 2. PWO, 2 of these. We have circle 1 and 2 are both this rectangle. So I don't have to figure this one out already. I've already done it one time. Now I'm going to work on figuring out another rectangle. Let's take this one here. Let's call this one 3. And 3 is the same as this one. So 3 and 4 will be the same. And now I'm just going to draw a picture over here for that one. Too many things in my head. Draw a rectangle over here that looks like that. It's definitely fatter and taller. So I've measured with my ruler. It's 28 centimeters. 28 centimeters. And it is 18 centimeters tall. Okay, so I'm going to put centimeters squared because I didn't put the units there. Okay. Area again, area formula, still rectangle, base times height. Be careful with those nets that aren't all the same type of shape. This one is, they're all rectangles. So now I'm going to substitute what I know, 18 times 28. 18 times 28. I have to figure out what that is. Can anybody think of a fancy way to do it? Versus just doing 18 times 28?
Boy, well.
In the interest of time, I did it on the calculator, and it's 504. Oh, that's a nice little bug there. 504 centimeters squared. I guess we could have done 110 times 20.
Yeah, that's what I was, that's what I would have done.
That works.
Yeah.
So, all right. Once again, there are 2 of these. I have 2 of them. There are
Xander, mute unless you're asking a question, Derek.
3 and 4. So I have 2 of those. I have 2 of those. And now there's 1 rectangle left I haven't done. It helps if you're labeling, and I would definitely do what he was doing on the nets. Okay, so now I have rectangle 5 and 6. I know that a rectangular prism has 6. We talked about that today. I can count them. I can always grab a tissue box or even a book. Books are usually right by you. Books look like rectangular prisms too. So I can count and see that that was the 6th one that I need. And so if I'm looking here, what's this side? I don't have it labeled. How long is this one? It's the same as this one down here. So I don't have to label every single thing. I can see that's the same as that one, which is again 28 centimeters. And now it's not 18 centimeters tall, it's just 5 centimeters tall. Same formula. It only takes me a minute to write the formula again. It gives me a chance to think a little bit too. 28 times 5. So 280, half of that would be 140. Does that seem right?
20 times 5 is 100. 8 times 5 is 40. 140.
Again, once again, we have 2 of those. So we have 2 of those, and they are rectangles 5 and 6. So if I want the surface area, I need to add all the areas. I have 2 of these. Here are the words of. This times 2 plus this. So one thing I could do, I could write now my next step out. I will write it down here. Am I off camera? Is it still okay?
So good.
Okay, so surface area, I could write it like Mr. Berger did. He did 90 and 90, and then 504 plus 504 plus 140 plus 140. That's what he did for his. He wrote them all out there. I'm going to kind of scoosh this out of my way for a second. Okay, almost. Or I could take what I know. I have 2 there. Or I could write it as 2 times 90 plus 2 times 504 plus 2 times 140. That might make it easier when I'm doing the math too. I know 2 90s is 180. I know 2 504s, well 2 500s is 1,000, 2 4s is 8, so this would be 1,008. And 2 times 140, 2 140s, 280. It's just another way of writing the same thing.
Using the distributive property.
Definitely. And then I can add those together as well. I can add 180 and 280. 80 and 80 is, I don't know, I have to do it this way. 280, I'm thinking about it this way. 80 and 80 is 16. 8 and 8 is 16. 460 plus 1,008 is 1,468.
I love that it's 180 because I know that 180 plus 180 is a full circle, which is 360 degrees. So I knew it was 360 plus 100.
Oh, very cool. Oh, I see what you did, 180 there. Nice. I like that. So that's the big thing for surface area is you're thinking about all the different areas you have in that particular prism. Again, if it's a rectangular prism, you're going to have 2 triangles. The 2 triangles will be the same, but the rectangles all 3 may be the same, 2 may be the same, or they may all 3 be different. You have to just be careful. And the other thing is making sure that if you know what one length is, thinking about the shapes aren't going to have every single side labeled, but I can reason this length must be the same as this one. And this one must be the same as that one. So looking for those congruent sides, those lengths that are the same. Anything you wanted to add, Mrs. Nelson?
I know, I think you did a great job and I like that. And I love that you showed the formula that for surface areas, it's 2 times the front and the back. You know, it's 2. You've got the front and the back, remember, the top and the bottom, the side and the side. So every time you're thinking about surface area, you're thinking that there are 6 sides, unless you're working with a different type of prism. So if I'm working with a triangular prism, and we asked in the earlier meeting, how are they labeled? How many faces is the triangular prism going to have?
So if I start talking, you can see my triangular prism right here. Here's a triangular prism. I'll turn it around, front and back. Here's the bottom. And here's a side, another side. How many faces does it have? How many faces and what are the shapes? You can think about it, or you can unmute and answer. How many faces are there? How many faces altogether? Can you hold up with fingers so we can see? How many faces are there? 5 faces, right? So I'm putting my fingers on them and then the 2 ends. 5.
Angel.
And then how many shapes? What kinds of shapes are they? 2 triangles. There's 2 triangles, and they could be squares, but for sure they are rectangles, and 3 rectangles. Each of the sides and the bottom make rectangles. So just thinking about if I cut it apart, it's helpful if you have these shapes around you, if you can find them at home, take a look around. I had to do a little hunting. If you can find them and see if you have a tissue box, a book, something around.
Oh, all right. I'm only telling this group. Tomorrow morning, maybe we'll do something that's a triangular prism. So go ahead and try to do that. Look for a triangular prism.
I highly recommend Toblerone chocolate, except I don't recommend anybody going to these stores. But if you have Toblerone chocolate,
all right, guys, and that's how you find the surface area of a rectangular prism or any prism. You total the sum of the faces.
Sum of the areas of all the faces. Good job, guys.